We can also calculate delta G by using the same equation that we used for delta H and delta S, the sum of the products minus the sum of the reactants. We said that when delta G is negative, the reaction is spontaneous, and when delta G is positive, the reaction is non-spontaneous. When delta G equals 0, the reaction is at equilibrium, which means that it's going in the forward direction and the reverse direction at the same rate. This is the point at which the reaction changes from spontaneous to non-spontaneous, or vice versa. So what we're going to do is calculate the temperature at which spontaneity changes. Our example says to calculate the temperature at which the reaction changes from spontaneous to non-spontaneous, which is at equilibrium when delta G equals 0. Our equation for delta G is delta H minus T delta S. Plug in 0 for delta G and rearrange the equation to solve for temperature. And pay attention to the units of delta H and delta S because they aren't the same. Convert delta S from joules to kilojoules before plugging it into your equation. (500 Kelvin is the temperature the reaction changes between spontaneous and non-spontaneous. But the second part of the question asks if the reaction will be spontaneous above or below this temperature. Since delta H is negative and delta S is negative, the temperature needs to be low in order for delta G to be negative, which means the reaction will be spontaneous below 500 kelvins.